everyone, welcome to video 2 of 2 on integrating powers of trig functions for Math 1452 at Texas Tech University. So in the first video, we went through the kind of rules for how to simplify and rewrite integrals where we have a power of one trig function times a power of another trig function. So in this video, we're going to be working through 3 different examples, one for sine and cosine, one for secant and tangent, and one for cosecant and cotangent. So let's just go ahead and dive right in. So first off, we're evaluating the integral sine cubed times cosine to the 4th. So let's just go ahead and identify our powers of these integrals. So our sine here has a power of 3, which is odd. And our cosine here has a power of 4, which is even. So we can scroll back up to the top here and see which of those 3 cases are we in. So our power of sine is odd and our power of cosine is even. So we're in this middle case. So for this middle case, we're going to factor out a sine and change the remaining signs using the Pythagorean identity, sine squared equals 1 minus cosine squared. So let's just go ahead and do that. So I'm going to rewrite this integral. So I'm going to isolate one of the signs, and I'm going to have sine squared left over, because remember, when I have my power of 1 here adds to my power of 2 to give me a power of 3. And then I'm going to have a cosine to the 4th. Okay, so now I'm going to change my remaining even powers of sine to cosines using the identity that sine squared equals 1 minus cosine squared. And now I'm going to simplify my integram. So what I'm going to do is I'm going to distribute this cosine to the 4th to my 1 minus cosine squared. But the sine x that I factored out, I am going to leave it. It's not going to change at all. So I'm going to have a cosine to the 4th of x minus cosine to the 6th of x dx. So I factor out my sine, and all the other terms in my integral are rewritten in terms of cosine. So remember that this means that I am going to use u equals cosine of x as my u substitution. So let me actually write that here at the top. So u equals cosine of x. So now I take the derivative of both sides. So du over dx, and the derivative of cosine is negative sine. And then I am going to rewrite this as du equals negative sine of x dx. And lastly, I'm going to solve for dx. So du divided by negative sine of x equals dx. So now I can rewrite my integral. So again, my sine is going to stay the same, but now I have u to the 4th minus u to the 6th, and I have du over negative sine of x. So we can see that those signs are going to cancel, and then we can put that negative in front of the integral sign, and I'm just going to have u to the 4th minus u to the 6th du. And this is something that we can integrate using the reverse power rule. So we are going to add 1 to the power and divide by that new power, and then we're going to add c at the end. Okay, so just for the purposes of illustrating how these integrals are going to work, I'm not going to solve them all the way through. I'm just going to kind of stop when we get to something that we should know how to integrate from Calculus 1 that doesn't add any of that new content. So that's how we're going to approach this example. So next, for example 2, we are integrating secant to the 4th tangent cubed. So again, I'm going to look at my powers. So my power of secant is 4, which is even, and my power of tangent is 3, which is odd. So I have an even secant and an odd tangent. So going back up, I have an even secant and an odd tangent. So this satisfies both A and B. So we can solve this whichever way we want. So we can use either one. There's going to be no necessarily good reason to use one over the other. So on the filled out version of this worksheet, I chose to factor out secant squared. So let's do the other one in this video and factor out secant tangent. So let's factor out a secant tangent. So I'm going to have a secant times a tangent. And when I took out one secant, now I'm left with secant cubed. And when I factor out a tangent, I'm left with tangent squared. So when I factor out a secant tangent, I am going to rewrite all of my tangents in terms of secant now. So I'm going to leave my secant tangent as it is. My secant cubed is going to stay the way it is. And my tangent squared is going to become secant squared minus 1. Okay. So now I'm going to rewrite the part of my integrand that doesn't contain the secant tangent, because remember, I factor that out and then I don't touch it again until I start my u substitution. So my secant tangent is going to stay there. And then I'm going to have secant to the 5th x minus secant cubed x dx. And now that the rest of my integrand is in terms of secant, I can use my u substitution. So u is going to be secant. When I take the derivative of both sides of that equation, my du over dx is secant tangent. I then use some algebra to solve for dx. So my dx is going to be du over secant tangent. Okay, so now I can rewrite my integral. So I have the integral of secant x tangent x times u to the 5th minus u cubed, and my dx is du over secant tangent. So again, the secant tangent that I factored out should completely cancel when I use my u substitution. And now I just have the integral u to the 5th minus u cubed du. And so again, we are just going to integrate this using the reverse power rule. Okay, so again, we just use u substitution to rewrite this integral. And lastly, we're going to look at the integral cosecant cubed times cotangent. So going back up, so remember we didn't explicitly write down what rules these were going to use, but let me identify my powers. So my cosecant has a power of 3, which is odd, and my cotangent doesn't have it written, but if it doesn't have it written, that means it's to the first power. So my cotangent also has a power of 1, which is also odd. So both of these powers are odd. So that means we're going to actually be in this middle case here. I'm just going to circle that one now. So we're going to be in that middle case. And so that means we're going to factor out not a secant tangent, but a cosecant cotangent and proceed from there. So when we factor out a cosecant cotangent, we are going to rewrite our integral like so. So when we factor out one cosecant, then we're left with 2 cosecants. And whenever we factor out that cotangent, we're actually left with none because we only had 1 to start with. So then we're going to rewrite our integral using the fact that cosecant squared. Well, actually, let me go back up and check. So do we need to rewrite our integral? So if we have any other tangents, so in our case, if we have any other cotangents, then we need to rewrite them. And that's actually not the case here. We factored out our 1 cotangent, so we don't have any more. So in this case, we actually just needed to factor this out, and then we could immediately start our u substitution. where u is our cosecant. And when we take our derivative of cosecant, we get negative cosecant cotangent. Again, we can use some algebra to solve for dx. So dx equals du over negative cosecant cotangent. And then we can just go ahead and rewrite this integral as the integral of cosecant cotangent times u squared times du over negative cosecant cotangent. And again, that cosecant cotangent will cancel, and we can bring that negative in front of the integral. And from here, we are just going to integrate using the reverse power rule, adding 1 to the power and dividing by that new power. And as always, we're substituting our u back in and then adding c. So in this case, we needed to go back and make sure we read our directions a little bit more carefully and that we didn't need to change that cosecant because the derivative of cosecant was that cosecant cotangent. So like I said, we only covered these cases that have the arrows up here. So in particular, we didn't cover case 3 in either the sine and cosine examples or the secant tangent examples, just because they work a little bit differently. However, we would recommend going to this URL here that is linked and seeing some more examples there. So you may have heard of this resource before. This is Paul's online math notes from Lamar University. And these have lots of different examples of these types of integrals. So look there if you want additional examples. But for now, we hope this helps and good luck.